All right, guys, Mr. Antonucci here, and in this video, I want to show you a quick example of how to use U-substitution with indefinite integrals. Now, if you remember from differential calculus, we had the chain rule, and this was how we differentiated functions that were composite functions. So a composite function is when you have one function inside another one. And so if I have f of g of x written like that, and I take the derivative of it, it's just the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Now, for sake of simplicity, if I have the function y equals x squared plus 4 quantity to the 6th power, you could multiply 6 factors of x squared plus 4, distribute and simplify all that, and then take the derivative. That's a lot of work. Here, you could think of this as a composite function where the inside, the g of x, that role is being played by the x squared plus 4, and the outer function is the power function of power 6. Now, when I take the derivative, you do the power rule on the outside, so 6 quantity to the 5th power, evaluated at the inside function, times the derivative of the inside, which is 2x. Now we could simplify that a little bit, moving the 2x with the 6 and give you 12x times x squared plus 4 to the 5th power. Now, U-substitution is kind of like a reverse chain rule. If you have an integral and it has a certain form where it looks like it's the answer to a chain rule problem, then you can use U-substitution. Let me show you with an example here. If I want to find the definite integral of x cubed times the square root of 4 plus 2x to the 4th dx, typically what you're going to do is you're going to let u equal the inside of something and then take the derivative of it to see if the function is multiplied by the derivative of the inside. So in this case, u is equal to 4 plus 2x to the 4th. If I take the derivative of that, du dx, you get 8x. Now, using differentials, we can solve for du, and du would be equal to 8x dx. Now, this almost lines up perfectly. The 4x squared, 4 plus 2x to the 4th is right there, and we have an x and a dx right here. I forgot the cube on there. That's why it doesn't line up exactly. So we do have our x cubed dx that lines up with the x cubed dx over here. However, you have an additional factor of 8. The nice thing about this is you can divide both sides by 8 or multiply both sides by 1/8 and get 1/8 du equals x cubed dx. Now here's the important part. When you use U-substitution, everything has to substitute in terms of u. All the x's and functions have to be in terms of u, as well as the dx. Now watch this. We can rewrite our integral. The x cubed and the dx are going to be replaced with 1/8 in du. The square root, the 4 plus 2x to the 4th, is going to be replaced with u. So you have 1/8 square root u du. Now everything is substituted in terms of u. I could rewrite the 1/8 as factored out, and then the square root can be written as the 1/2 exponent. Now, so far up to this point, I haven't done too much calculus except for getting the derivative of the 8x cubed. Here is where we want to do the antiderivative. The antiderivative of u to the 1/2, you add 1 to the exponent, multiply by the reciprocal of the new exponent, and don't forget that 1/8 that was already out front, and remember your plus c. Now, one thing that I notice students often forget is they'll get to this step, they might simplify the 1/8 and the 2/3, and they forget to back substitute to get your answer all in terms of x. This is a very important step. If your indefinite integral begins with a variable, you want your final answer to be in terms of that same variable. So 1/8 times 2/3 is going to give you 1/12. And then the u, you could back substitute what u is equal to, 4 plus 2x to the 4th to the 3/2 power plus c. And that, ladies and gentlemen, is our antiderivative using U-substitution. So remember a couple things here. You can use this as kind of a reverse chain rule, but make sure everything substitutes in your final answer is in terms of the variable that you started with, as in the case here, we started with x. So I hope that was helpful to you. If you like this video, please do subscribe to the channel and hit the bell for notifications so you get notified when new videos are uploaded. And if you have a question that you'd like me to make a video on, put it down in the comments and maybe I'll make a video of it. All right, take care.